This is DarkLoader. This is the program that most people used to load and play their Thief missions before the advent of NewDark. Don't use this, by the way, this is just for demonstration purposes. The way DarkLoader works is that you give it a bunch of folders with fan missions in them, and then you give it your Thief directories, and it scans all of your fan missions when you click on them, and it detects their game type, whether they're for Thief 1 or Thief 2 or System Shock 2. It doesn't support Thief 3. So you can see when we click on a mission, it's going to detect the game type. That's for Thief 1. If we scroll down a little more here, we might get to some Thief 2 missions. That one's for Thief 2, etc. Now, for old Dark missions, this worked perfectly fine, but one of the very first things that people noticed when NewDark came out was that DarkLoader no longer would detect the game type for NewDark missions. It would think every NewDark mission was for Thief 2. So you can see here, for example, we have, say, Calendra's Cistern. This is for Old Dark, and it detects it correctly as a Thief 1 mission. We can see that it says Thief the Dark Project. It's for Thief 1. However, if we go down here to something more recent for Thief 1, say Chalice of Souls, we can see it actually detects it as Thief 2, even though it says right down here, this is a Thief Gold mission. Now, you can work around this by opening up the DarkLoader config file and setting these missions to Thief 1 manually, which is what many people did at first, including myself. But clearly, DarkLoader was not designed to work with NewDark missions. It was made long before NewDark came out. So NewDark comes with FMSel, which is its own FM loader. And the way FMSel works is kind of the inverse of the way DarkLoader works. Rather than being one app that gathers up all your missions, scans their game type, and just lets you play them, FMSel actually has a different, separate instance of this DLL for every game that you have installed. Thief 1, Thief 2, Thief 3, and System Shock 2 each have their own copy of FMSel and their own config, and when you start the executable, FMSel starts for that copy of the game, and it actually does not do any game type detection at all. It assumes and expects that all of the FMs that you give it are in one folder and that they will all be of the correct game type. So this is the Thief 2 FMSel, so it assumes and expects that everything in here will be a Thief 2 FM. It doesn't detect at all. Now, that works as long as you know that that's the catch, but a lot of people, myself included, don't really find FMSel to be satisfactory in terms of user interface compared to DarkLoader. With DarkLoader, you've got this nice README that's just right here, and when you run the game, DarkLoader continues running, so you can Alt-Tab out and look back at the README, or, you know, change things if you want. Change your comments, say. But with FMSel, you can tell FMSel to come back after you've quit the game, but you can't have it running at the same time as the game, and also it doesn't show the README here, and in general, I and many others find the interface not as quick to work with. Now, a few years after NewDark and FMSel came out, another loader was released, NewDarkLoader, and this was designed to look like DarkLoader, but to work like FMSel and therefore support the NewDark missions properly with the NewDark API and so forth. And I myself used this for several years, but I still found myself wanting a loader that not only looked like DarkLoader, but worked like it as well, and that's why I created AngelLoader. But the problem was that if I wanted it to work like DarkLoader, I was going to have to find a way to detect the game type of NewDark fan missions accurately. So that's what this video is going to be all about. So the first thing that I tried to figure out was, okay, how is DarkLoader detecting game types and why is it failing with NewDark? If you think about it, at first it seems like there must be some really easy way to tell the two games apart. Surely there must be some simple tell. But it turns out things are more tricky than you might imagine. So the first thing I did was to look at DarkLoader source code, which fortunately comes right with it. Now, this is in Object Pascal or some dialect of Pascal, and since I don't have an editor that can really open these, I decided to just use a file seek and just simply search within any .pas file. And let's search for, I don't know, SS2. Maybe we get some matches for a game type if we search for SS2 in here. I mean, I'll spare you all of this research, but this is basically what I did. But what I eventually found was this little section here is where the game types are being detected. And if we look at this code here, it's saying it looks like it's searching a zip file, and we've got a mission names array, the 0th element. So mission names up here, it looks like we are doing some kind of file search, and we're saying if we find a file extension with .mis, then we add that to mission name. So it looks like we're searching the first mis file here for these phrases, SKYOBJVAR and map param. Now, if you look at the code here, this is the variable, so we're saying if I equals 1, which I guess is the first element, that's SKYOBJVAR. So if we found SKYOBJVAR, then I guess we're saying it's thief2 or thief2x. Again, we can ignore this thief2x. Thief2x isn't an actual game, it's a fan mission campaign. I don't actually know what this deal is, but let's just focus on thief2 here. So if it finds this phrase, it thinks the FM is for thief2, basically. And if we see I equals 2 here, which would be map param, then it thinks it is SS2. So here must be the source of our problem. Basically what the problem is here is that the phrase SKYOBJVAR here, with old Dark missions, this phrase only appeared in Thief2 missions. It didn't appear in System Shock 2 or in Thief 1 missions. But with NewDark, SKYOBJVAR actually appears in all missions, Thief 1, Thief 2, and SS2, which is why DarkLoader thinks all missions for NewDark are for Thief 2. It actually even thinks SS2 missions for NewDark are for Thief 2, and that's actually just because it searches for SKYOBJVAR first, and since it's always going to find it with NewDark missions, it's always going to think they're Thief 2. If we actually switched the order of these, that would actually fix detection for NewDark System Shock 2 FMs, but it still wouldn't help us for Thief 1 FMs. So I'm thinking, okay, the first thing I thought of is maybe I should try searching for a different phrase. Surely there's a different string of text that is still going to only be in Thief 2 missions that we can use to detect it. I can just, swap this out with that and we're good. Unfortunately, I looked for a whole bunch of different strings that I found to try to find one that was unique to Thief 2. Could not find any with a quick eyeball search, which actually surprised me because, as I said, it seems like there'd be a really obvious way to tell these two games apart, but there really kind of isn't. They're very, very similar. But as I was looking through these misfiles in a hex editor to try to find phrases, I actually noticed something. SKYOBJVAR, if you search for it here, I noticed that in a lot of missions it was sort of right here near the start of the file, right? But then if we pick another one, say something like this, say, and you look at one of these missions, if we search for it again, it actually occurs quite a ways further into the file. And I was looking through a whole bunch of files, and I really noticed this pattern. The positions seem to be the same, way down here or right at the same place kind of up here. And it got me thinking, I wonder if the positions are consistent. I wonder if SKYOBJVAR appears in one position in Old Dark and a different position in New Dark, and I wonder if its position might tell me anything about whether the game is for Thief 1 or Thief 2. So I wrote a program that would scan every single misfile that I had, and it would spit out the byte location of SKYOBJVAR if it found it, so that I could look and see if I could find commonality between the locations and find any differences. And it turns out that what I found was, for Old Dark Thief 2 missions, SKYOBJVAR always appeared at byte position 772, while for New Dark missions, SKYOBJVAR appeared at one of two other positions, either byte 7217 or 3093. And I thought, bingo, I'll bet one of these locations corresponds to Thief 1 and one corresponds to Thief 2. So I tested it. I went through all of the missions and manually checked their game type and then compared it to their location of SKYOBJVAR. And it turns out that isn't the case. They don't tell you which game it's for. In fact, it's to do with the NewDark version. I believe NewDark 1.19 has SKYOBJVAR at the 3093 position, and all subsequent versions have it at 7217, but it's nothing to do with game type. So that would tell me if the mission was for Old Dark or New Dark, which is kind of neat, but it doesn't help the problem at hand. So back to the drawing board. So at this point I'm thinking, okay, there has got to be a unique string in here somewhere. Seriously, there has to be one. It is like totally improbable that there isn't at least one. So I thought, okay, I'm going to see if I can find a mission, because I know there is at least one, maybe two, that have been released for both Thief 1 and Thief 2, a Thief 1 version and a Thief 2 version with minimal to no changes. I know there was one, it might have been Tower of Moria, but it could have been something else. I can't quite remember. But I looked, and I actually found one, and that mission was Dead Knight Sweet Delight. You may remember my Let's Play of it. It was from the NewDark 64 Cubed contest, it might have been. Anyway, the mission is by Mystery Man, and it has a almost identical version for Thief Gold and Thief 2. So I took the two miss files, and I wrote a program to scan through them and find ASCII strings longer than 3 or 4 characters, I think it was, and printed them out into 2 files, and I compared them. And here are the results. Here's file 1, and here's file 2. This is for Thief 1, and this is for Thief 2. So you can see we've got a very short list of strings here, so this is both good because it's not going to take us forever to look through them, but it's also really nerve-wracking because it's like, look, if we don't find something in this short list, we are screwed here. So we can look through the list. We've got Finordvox, we've got Test Voice. These all kind of look like voice sets or global type things. We've got, you know, Water HW, that's a texture. So, I mean, normal's normal. This doesn't really look all that promising. This kind of just looks like resources. I don't really see anything in this Thief 1 list, but let's look through the Thief 2 list. We got a bunch of V stuff, which is probably a voice set. I'm not terribly familiar. But now we come across this phrase here. Ropey arrow. Just in the middle of the voice sets. Ropey arrow. Now, an explanation about what ropey arrow is. In Thief 1, you have rope arrows, and in Thief 2, you have rope arrows in some missions and vine arrows in others, and they both are on your rope arrow key, like your 8 key by default, right? So, in the second game, because you could have 2 types of arrows, they called this arrow sort of base archetype, I guess, if you will. I don't know if it's actually an archetype, but they called the concept of a rope arrow ropey arrow because it could be either a rope or a vine. And this extra lowercase y is our savior because this phrase is our phrase. This phrase, and I checked this by scanning every single misfile and manually comparing its game type to a known correct game type, that every single misfile that contains ropey arrow is for Thief 2, and every single misfile that does not contain it is for Thief 1, or System Shock 2 if it has map param. This is our phrase. And so actually, Mystery Man is kind of the unsung hero of AngelLoader. If it weren't for him making this Thief Gold and Thief 2 mission, I might never have found this phrase. So thank you, Mystery Man. You are the man of mystery. So I'd like to just show a demonstration here. We've got this text file here, which is all of the missions in this particular test set. I've gathered a bunch of missions, Thief 3, Thief 1 and 2, SS2, and then some more NewDark Thief 1 missions in there. This is a list of all of these missions with their known correct game type. So we're going to use this as the base list that is known accurate, and we're going to scan with our newfound phrase, and we're going to see if our game types are 100% accurate. So here's the scanner that's going to use our phrase. Let's run it. And I'm going to use this little utility to make sure that our disk cache is clear, meaning that we're going to be reading straight off the SSD, and we're not going to be reading any files from memory. So this is going to be a totally cache cold thing so that we can see the disk-based, disk-bound performance of our scan. We're going to see how accurate we are and how fast we are. Let's go. Okay, so we're done, and we can see that took about 49 seconds. So that's not terrible, but, you know, let's see how accurate we are. So what I'm going to do, we should have a new file here, game types working, and I'm just going to compare these two files. I'm going to diff them using this simple utility, and what we're looking for is for the files to be exactly identical. And they are. So that means our scanner is 100% accurate for detecting Thief 1, Thief 2, and System Shock 2, also Thief 3. I haven't gone into Thief 3 here because Thief 3 is actually extremely easy to detect because the folder structure is completely different. You basically detect if it has a particular folder with files with a particular extension in it, and if so, then it's Thief 3. It's easy, it's not particularly interesting, but we're still accurate with that, and if you're interested, you can kind of see the code, let's see. Right about here, it's basically looping through the files in the FM, and it's just seeing if it has a particular path, content T3 maps, and then it's just checking if it has any files with these extensions, and if so, it's Thief 3, like I said. Pretty trivial. This is the tricky bit. Okay, so we're accurate. So we could just call that done right now and be perfectly great. But you know what? 49 seconds, that's kind of a long time. I wonder if we could do better. Well, it turns out we can. In fact, we can do a lot better. But I'm going to have to get into some technical details in order to explain how. So here we go. The first thing you may remember is that I said that for Old Dark Thief 2, SKYOBJVAR always appears at byte position 772. That means that what we can actually do is we can simply check byte position 772 and the next 9 bytes after it and see if those are SKYOBJVAR. And if they are, we instantly know the mission is for Thief 2 and we can just end the scan right there. That way, we've only had to scan 9 bytes instead of the entire file, and we're already done. So for Old Dark Thief 2 missions, if you've got a lot of those in your collection, the scan for those will be almost instant. So that's one way we can get really fast. Okay, so I've added some code here to do this early out check for Old Dark Thief 2 missions. So let's run this again, making sure our cache is empty here, and let's see how fast we are now. So we can already see right in the middle there, we're moving really fast compared to before, and that is our Thief 2 Old Dark mission section being scanned very, very quickly in the middle there, and we slow down again towards the end as we get into the NewDark stuff. Okay, so now we're done, and now we're only taking 32 seconds. That's a huge time savings. But guess what? We can do even better. We are just getting started here. Oh, and let's just check our accuracy. Good, we're still accurate. Awesome. Now, one other easy thing we can do is that just as SKYOBJVAR only appears at a specific couple of positions, so too does mapparam, in fact. So we can actually early out the mapparam search as well and make things a little faster if we have SS2 missions. So here I've updated the code to do just that. Now let's run again and see how fast we are. Well, it looks like we're about the same speed. I mean, after all, we only have a handful of SS2 missions, so it looks like that's not really affecting us too much. But there's a lot more that we can still do. But I'm going to have to start explaining some tech stuff now for real. So, what we need to know in order to be properly fast is just how a misfile is structured. So, the structure of a misfile is actually pretty simple. The first thing is a number, which is the index of the table of contents, which is actually located at the end of the misfile. Don't know why, but before that, after the index and before the actual table of contents, this is your main data. These are chunks, so each chunk of data has a name, and then there's the data after it. Now this is actually a slight simplification. There's a few more numeric fields in here, but they don't actually help us, so we're just going to ignore them for the sake of simplicity. Basically, you've got a chunk name and your chunk data, and they're all just packed together, and your table of contents has a chunk name, the index of that chunk, and the length of the chunk. So how it works is, you basically got your index, which points all the way down to the index of the table of contents in the file, and then each chunk index points back up to the index of the actual chunk in the data. So if you want to read a misfile, you basically have to read the top, skip to near the end, and then search through here until you find the chunk name that you're looking for, and then jump back to the middle where your chunk actually is, and then read it. Now, under normal circumstances, that's not really a big deal. You just kind of follow the signposts, and you might just kind of raise an eyebrow and go, huh, and then move on with your day. But this is actually going to have some fairly substantial ramifications for us. Not necessarily positive, but we can work with them. So this is the first thing to know. The second thing to know is that for AngelLoader at least, we need to scan both zipped FMs and unzipped FMs. So for scanning unzipped FMs, if we're just taking the misfile straight off the disk, we can just do, like I said, you look at the index, you read the chunk name, and you go and read the chunk data to read a particular chunk. Now, why do we need to read a particular chunk? Well, it turns out the ropey arrow phrase is always in a chunk called obj_map. It's always within there. So one way we can make our scan a lot faster is knowing that it is narrowed to just that chunk, so we don't have to search any other part of the file. We just have to get that one chunk and search that for our ropey arrow string, and that'll make us a lot faster. The problem is, with zip files, you can't actually randomly access a zipped file inside of a zip archive. You can random access to the start of each file inside the zip archive, but you can't actually jump around in the middle of a compressed mis file or any file. So we're in a bit of a pickle here. We need to search for our phrase ropey arrow. We don't want to scan the entire file for it. We only want to search the one chunk, but the problem is, if we want to find out where that chunk is, we would basically have to go all the way to near the end of the file, then back up to somewhere in the middle. And with a zip file, the reason you can't randomly seek is because you can only decompress forwards. So we would be taking a compressed mis entry, decompressing from the start. We would be reading this number, and they would have to decompress all the data to near the end of the file, and then we could jump back and find our chunk. But that would actually nullify all of our performance increase, because we would already be decompressing most of the file anyway, so we don't want to have to do that is the whole point. So what can we do with a zip file? Well, the best we can do is to simply search it in, well, I don't want to say chunk because it's not this kind of chunk, but like a portion of data. We don't want to read the entire thing into memory, decompress the whole thing, and then look back. Instead, we're going to do a simple brute force search. We're going to start in 81K chunks, 81920, 81,920 byte chunks, and we're going to decompress them chunk at a time. So we're going to get the first 81K chunk, we're going to search it for ropey arrow. If we don't find it, we're going to get the next 81K chunk, and as soon as we find it, we're just going to early out the search. So it's not as good as if you're uncompressed, but it's the best we can do with a compressed stream, so that's what we're going to do. Okay, I've added the code to do that. Now let's run again and see our performance now. Okay, so we're at 28 seconds. Well, we've saved 4 seconds. That's not a colossal amount saved, but it is measurable. And it looks like for zip files at least, we are now as fast as we're possibly going to get. I mean, we're doing the 772 byte early out if we can. We are doing the map param search at particular byte locations and earlying out if we can. We're searching the zip file chunk by chunk and earlying out just as soon as we can for that. We really can't get any faster. Except we can. Because guess what? The mis files are not the only files we can scan for key phrases. We can also scan GAM files, because they actually have the same thing going on. If they have ropey arrow, they are for thief 2. If they don't, they are for thief 1. I actually don't even remember how I even thought of this, but it is a massive killer of a find, because mis files have a hugely varying file size, right? So basically what we're doing with a zip is we're just brute forcing all the way through the file. So if we find ropey arrow, let's say, I mean, I don't know, I haven't measured this, or if I have, I've forgotten, but let's say ropey arrow might on average be halfway through the file. If we find it, we're going to scan halfway through a file, and if we don't find it, we're going to scan all the way through a file. And a mis file could be anywhere from a few hundred K to upwards of 150 megs in some cases. So we would be scanning through dozens, sometimes over 100 megs for our ropey arrow phrase if we don't find it. And even if we do, we might on average still be scanning through half of that. Whereas GAM files are never more than a handful of megs. So if our missions happen to have GAM files in them, we can scan those instead and save massive amounts of scan time by only scanning a handful of megs instead of dozens or 100. This is awesome! Also, I noticed we haven't been checking accuracy. Sorry about that. Let's check it again. We are still accurate. So, as I said, this is awesome. Okay, I've now added the code to scan GAM files if they exist. Let's scan again. We are now at 10.6 seconds. Are we accurate? We are. This is amazing. This is as fast as we can now get. And it is blazing. We went from 49 seconds to 10.6. And that's how you do it. But there's actually one more small matter. And the astute among you may possibly have noticed. But let's look at the code again. Now, if we see in this in this code that we've got here, we are looking for SKYOBJVAR at byte position 772, right? If we don't find it there, we are then doing the full file ropey arrow scan, which is sort of a fallback, if you will. For System Shock 2, we're searching for map param at specific byte locations, right? But if we don't find it there, we don't have a fallback. Now, this is 100% accurate currently, and it's unlikely but possible that some future NewDark update might move the byte positions for map param again. Unlikely, but it could happen. And if there happens to be a new System Shock 2 mission released with that's made for a new NewDark version, a future NewDark version, and that future version happens to move the byte positions or add a new potential one that we're not accounting for here, we are going to miss that, and we're going to misdetect the mission as being for Thief 1. Again, vanishingly unlikely, but there's something we can do to greatly minimize the chance of any error here. And that's what I call fingerprinting SS2. So basically what we do is when we are looking through the files of the mission in here, where we're detecting Thief 3, we are also fingerprinting SS2. So basically, we have these files here, which are files that are commonly found in System Shock 2 missions. So, use message.stir, save name, an object and stuff. And then we've got all of the stock SS2 miss names. And if we find any of these files, then we say that System Shock 2 has been fingerprinted for this FM. It is most likely System Shock 2. Now, the reason we do this is so that we can avoid having to scan the entirety of a mission again for the map param phrase, just in case it might be found somewhere else. That would make us horrendously slow again, and instead of doing the ropey arrow scan through the whole file, we'd have to also do a second map param scan through the whole file. So that would be really bad, because we'd have to do that for every Thief 1 FM just in case it's SS2. So we don't want to take that performance hit. So that's why we do this fingerprinting. If we fingerprinted the FM as most probably being for System Shock 2, and we have not found ropey arrow or map param or SKYOBJVAR at the byte positions in the mission. In other words, if we haven't detected anything else and we think the mission is Thief 1, and we have fingerprinted SS2, then and only then do we do a full miss scan for the phrase map param. And this is just future-proofing again in the vanishingly unlikely case that map param ends up at a different byte position in the future. This is almost certain to catch it, and it will give me time to put out a new version of AngelLoader which supports the new byte position, and people will probably not get misdetected there. Almost certainly not in what is an already completely unlikely situation. You don't really have to do this, but I did because I just love coding and being thorough to a point that is completely unnecessary. So that's basically how the scan works. There's also a couple of other optimizations that do make AngelLoader just a little bit faster. One is that we actually don't just grab the first misfile we see, we grab the smallest misfile, so that if in the event that we do have to do a full misfile scan, we're at least scanning the smallest possible one. We also get the smallest possible GAM file. That's optimization. There's also another thing we have to do. We can't just grab any random misfile. We have to get a list of used misfiles, because some FMs contain weird, dummy, invalid misfiles that are just random garbage data, and we have to actually know if the misfile we're going to read is actually used by the game or not. So we have to do that little detect. And if you're interested, the way we do that detect is that we look for a misflag.stir file here, and then we just cross-reference this file with the actual misfiles. So you see in Broken Triad, for example, there's 3 misfiles. One of them is suspiciously smaller than the others. So we actually look at the misflag.stir and we say, okay, we're going to look at the number at the end of the misfile, 20, 21, and 22. And then we're going to look at the numbers here. And any number that does not have skip, we're going to say this is a used misfile. So miss 20 doesn't have skip, that's used. Miss 21 doesn't have skip, that's used. Miss 22 does have skip, that is not used. So we're only going to scan these 2 valid ones and not this invalid one there. Now, as for unzipped reading, we don't have to do any of this crazy search through the MIS file, try to find the smallest and all of that. As I said, as you can see by the code here, we literally just do what you're supposed to. We go and look at the index, and then we look at the object map chunk, and then we search it for ropey arrow. And there you go. We're nice and fast. So that part's easy, but I wanted to explain the zip part because that's the much trickier one and why we have to have this complexity for the sake of performance. So that's how AngelLoader detects game types accurately and blazing fast. Have a nice day. Yeah. Also, I forgot to zoom in the DPI for the rest of this video. That's just my adorable, unprofessional nature.